Hello, now we have discussion about the encoder in this lecture. So we know that encoder perform the inverse operation of the decoder, and encoder is used in the transmitter section when we are going to transmit the data. So now in case of encoder, we have to the n number of inputs, that is going to produce the n number of outputs. So here we have taken example the truth table for the octal to binary encoders. So since it is the octal, so here we have combination D0 to D7 and it will have binary equivalents. So this is the size of 8 cross 3 encoder. So here we have 8 inputs and we are going to get the 3 outputs. So three outputs means again with the help of 3 bits, total how many combinations are here. So that is the again 8 combinations. So we have written here from the 000 to 7. We are going to see how we'll obtain such type of the combination here. So now here it is assumed that up to this part is the input, okay, and from here x, y, z is here our output. Now here it is assumed that at a time only one input is high. Like here if you see that first we have D0 is 1, remaining are the 0. D1 to D7 is 0. So here subscript is what 0. So it is the XYZ we have written for the consideration you can correlate like this. So XYZ having a combination that produce the decimal 0. Again, we have second row. If you see that D is 1 here, so that with the help of binary, we can write 001 with the help of 3 bits. So combination has written like this. Similarly, if you see here D5, so D5 in the binary, we are going to write 101. So it is written like 101. So similarly, if you have D7, so D7 binary is 111. So like this, we are able to write the truth table. And here condition is that we have assumed that at a time only one input is high. If suppose at a time one input is not high, then what will happen? Then it will produce the undefined combinations. Like suppose for example, if at the same time D3 is 1 and as well as D6 is also 1. So generally, if only D3 is 1, so here what is the combination? It should be 0, 1, 1. Okay. And when D6 is 1, then combination is what here? 1, 1, 0. So now what will happen here in case of encoder, when both inputs are high, then it will produce the output as 111. So that 111 is actually output when D7 is 1. But here since D3, D6 is both are 1, so it's not going to satisfy. Either we have D3 is 1 or D6 is 1. We are getting the different output. So that can be overcome by using the parity encoders. So when two having high input at the same time, so higher parity will be transmitted first. So in this situation, D6 will be given as the higher parity. That we'll see later when we'll discuss about the parity encoders. So now in this, if you see that in this scenario here, if you see the x will try to calculate or y on z, what is the Boolean function for that? So if you see here z, so when z is 1, whenever z value is 1, what is the value of the input there? So like z is 1, so here corresponding value is what here? D1. So D1 is written here. Again, this corresponding value is what here? D3. So D3 is written. Again, corresponding value is what here? D5. So D5 we are going to write here. Again, last one what we have? Z is 1, that is the here D7. So like this we got Z equal to D1 plus D3 plus D5 plus D7. So Z can be represented with the help of OR gate, since it is the combinations, it is sum of the terms, so it is represented with the help of OR gate. Similarly, we can see the another combination also for the Y, how we are going to get the, these are the sum of the terms. So again, Y, when Y is 1, so this Y is 1 here, corresponding D2 is what here? D2 is 1. Again, when Y is 1, corresponding which input is 1? D3 is 1. Again, Y is 1 here, corresponding which input is 1? D6 is 1. Again, Y is 1 here, and corresponding D7 is 1. So that's why we are getting like this. In the similar way, we look for the X. So when X is 1, so if you see that here, X is 1 here, so D4 is 1. X is 1, D5 is 1. X is 1, input side, D6 is 1. X is 1 here, input side, D7 is 1. So that's why X is the written as the sum of D4 plus D5 plus D6 plus D7. So this one we can implement with the help of OR gates. So here we have three outputs. So three OR gates are required. So this one we can use for the suppose to represent the Z here. So corresponding here, four inputs are there. So those inputs will be connected. So we can represent the common inputs. From that, we can take the wire connection. So in this case, this is the D1, this is D3, next we have D5 and D7. Like this, we have another for the Y. If this OR gate we are going to use for the Y. So here inputs are again, four inputs are there. So each OR gate we are saying that it has four inputs. So here inputs are D2, this is the D3, this one is the D6, this one is the D7. And last one we are going to use for the X. So again, X also having four inputs here. So those inputs are, what are the inputs here? D4. Again, we have D5, D6, and D7. So like this, we are able to design encoder with help of OR gates. And what is the problem in this encoder that will overcome in case of parity encoders? Like we have taken the example when D3 and D6 both are going to be 1 at the same time, then output we got that triple 1. But in general, in case of parity encoder, D6 will be given higher parity and output will be 110. So here we have designed the normal encoders with the help of OR gate for the truth table, which is taken as the octal to binding encoders. And size of the encoder is here 8 cross 3.